Once again, welcome to the course Oracle Grid Infrastructure and Real Application Clusters Administration. Because you know me, I will skip the introductory slides about myself and about the Euclid IT School. And of course, the outcomes, once you complete this training, you will gain good understanding of Oracle RAC architecture. You will also hands-on install and configure Oracle RAC, and you will learn Oracle Clusterware administration and also Oracle ASM administration. Especially if you are new to Oracle ASM, you will understand Oracle ASM and learn complete administration of Oracle ASM. And finally, you will become familiar with the RAC database administration. So these are the outcomes of this training. And the course details, this is a live online training. 4 weeks is the duration, Monday to Friday. We will have classes during the same time, 7 a.m. to 8:30 a.m. IST, Indian Standard Time. And the lab, coming to lab, you can practice on your laptop or desktop, any personal system you may have. I will demonstrate every lab live in the class. You can follow, and every class is recorded. You will have access to the recordings for next 12 months. So you can replay the recording, watch the recording, and practice. You will also get a copy of the slides, and I have a lab guide with step-by-step instructions for every lab. So you can even follow the lab guide while you practice offline, or you can follow the class recording and the practice. And you will have lifetime support anytime you have any question regarding RAC at a later stage. I'm always available to you. You can contact me. And you will also have access to my VIP group, exclusive group for my students across the world, so that you can reach out to me in case of any question or clarification or any issue even in your project. Based on the issue, I might be able to support you. Okay, so that is the benefit. And the course curriculum, we have very extensive course curriculum. We'll start with the basics of Oracle RAC. You will understand the concept of a cluster, what is cluster, why cluster, types of clusters. You will understand what is real application clusters, why real application clusters, and the infrastructure required to implement real application clusters. Then you will understand overview of Oracle ASM and Oracle Clusterware. So that is the first part, first module. Then in the second module, it is all about installation configuration of RAC, because a RAC requires a different infrastructure and different components to be installed and configured. You will hands-on understand RAC installation and configuration in this second module. Once installation is done, then starts the administration part. RAC includes 3 softwares: Oracle Clusterware, Oracle ASM, and finally Oracle database, of course RAC database. You will learn how to administer Oracle Clusterware, which provides the clustering solution required for RAC database. Then you will understand ASM administration, which is the storage management software to manage the storage for Oracle database. Then in the last module, you will learn RAC database administration. So you will go through all these modules in this sequence, and by the end of this training, you will fully understand and hands-on administer RAC environments. So with that, let us start the first class. Being first class, we will go through the basics. And to start with, first we will refresh single instance Oracle database knowledge. You know you are already managing single instance Oracle database. We will refresh the knowledge about this, and we will see what are the drawbacks in single instance Oracle database and why you need a RAC database. So that is the main intention of reviewing the single instance Oracle database concepts. You know, single instance Oracle database has a database and one instance. Instance is the engine where the data is processed. Data is stored in the database and processed inside the instance. So every Oracle database will have at least one instance. A single instance database will have only one instance. And this instance and the database is deployed on a single server, standalone server. And the applications connected to the instance to access the data from the database. So this is what single instance database is all about, right? Now, here, let us see how single instance database can tolerate the failures. So failures are very common in IT, in any environment. Database environment is no exception. There could be different types of failures. There could be a process failure, that is software failure. There could be instance failure. There could be hardware failure, server failure. Any failure may happen at any time. So when a failure happens, how a single instance database handles that? For example, the most common failure in a single instance database is instance of failure. So when an instance fails, that is software level failure. When an instance fails, what happens? Because you have only one instance, your applications will disconnect from the instance. So without instance, there is no way for the applications to connect to the database and access the data from the database. So that will impact your applications. So your applications cannot access the database now. So that is the impact. Then second type of failure, which is quite common, is the server failure, the system failure. So a server failure also will have the same result. When a server fails, the instance, the database, everything deployed on that server is not available to the application. So that way, single instance database does not provide a high availability to your applications. So any failure to the instance or the server will impact the database availability. And single instance database has another issue or drawback in the form of scalability. Because you have only one instance, it can support a certain amount of workload. Because each instance has a limitation on the amount of workload it can support, right? So a single instance can support a limited workload. Now, if your workload is increasing, what would you do? Probably you might increase the instance size by adding more memory. And ultimately, you will run out of memory. So either you may have to upgrade the memory on your server. Again, after upgrading, you can do it for some extent. You cannot go on upgrading the memory. Ultimately, you will hit the hard limit of the server. So you cannot add more memory and resize your instance. And what next? Probably you might buy a bigger server, okay, with more resources and move your database to the new server. Again, for some time, you are good. You can handle the workload. And again, ultimately, as your workload increases, again, the same issue. So every time you cannot change the server and move your database from one server to another server. That is not the real solution. So ultimately, you are limited, okay? Your database is limited, how much workload it can handle. So single instance database cannot scale well, or it doesn't provide the required scalability for your application. So these are the two main drawbacks in single instance database. However, single instance databases are easy to manage because they have only one instance and less cost. But the only drawback is they are not suitable for critical applications which require 24/7 availability from the database. So that is what you get with single instance. So just to summarize, single instance databases, single instance Oracle databases are deployed on a single or standalone server or system. They does not provide a high availability. They does not provide scalability, or they provide a limited scalability, and hence suitable for non-critical workloads, which doesn't require 24/7 availability for your database. But today, most of the applications are 24/7, right? Such applications require 24/7 availability from the database. So that is where a RAC database comes into picture. But before we understand the RAC database, let us first understand cluster. What is a cluster? Because a RAC database is deployed on a cluster. So first let us understand cluster. What is a cluster and why you need a cluster, and different cluster architectures. So first, what is a cluster? A cluster is a group of servers known as nodes working together as a single system. So instead of a single system, you have a group of systems, but they work together as a single system. So from application perspective, it is like a single system, but you have many servers inside the cluster. So each server is called as a node. For example, in this cluster, we have 3 servers. This is called a 3-node cluster. Clusters are generally defined by the number of nodes. So if you have 3 servers in the cluster, it is called as a 3-node cluster. If you have 5 servers in the cluster, it is called as 5-node cluster. So that way you can implement a cluster, and your applications can be deployed on the clustered infrastructure. Why cluster? Clusters are in general more reliable, scalable, and effective than using a single system. We learned a single instance database which is deployed on a standalone server, a single server, a single computer. So when you have more than one of any, it is generally advantageous, right? Best example is a human body. We have 2 eyes, 2 ears, 2 hands, 2 legs, right? So best example is a human body. Everything more than one is always better. So when you have multiple servers, it is always better. You can tolerate a failure of a server. So that way a cluster is always advantageous, better compared to a single server. So you have a cluster of 3 nodes, and now you can deploy your application on this cluster. So on this cluster, you will implement Oracle database and deploy your application. All right. Now, if one of the server fails, in other terms, if one of the node fails, you can tolerate, your application can tolerate that because you have the database running on other 2 servers also. So failure of one server will not impact the database availability. For that matter, you can tolerate n-1 nodes failure. Meaning, if you have 3 nodes in the cluster, you can tolerate n-1. That is 3 n-1 is 2. 3 minus 1 is 2. So 2 servers can fail at the same time, but still your database is available because the database services are deployed on all the nodes in the cluster. You can choose on how many nodes you want to deploy. You may deploy on all the nodes, or you may deploy on fewer nodes. It is up to you. So depending on how many nodes you have deployed your database services, your database can tolerate n-1 node failures. So only scenario when your database is not available to the application is when the entire cluster fails, which is generally a disaster, a data center level failure. Otherwise, server failure, software failure, okay, will not impact the availability of your database, unlike in single instance database. So traditionally, many companies used clusters to provide availability and scalability. Scalability is also another factor. When you have multiple servers, your application can take advantage of combined processing power of all these servers. From application perspective, it is a single system, right? And the resources from all these servers are pulled together. Suppose if you have one CPU on each server, your application can benefit from the combined CPU, that is 3 CPUs. And similarly, memory, similarly, storage. So all the resources from these individual servers are pulled together, and your application benefits from this combined power. And not only that, you can add more nodes to the cluster as required. Today, you must have deployed a 3-node cluster, right? Your workload is increasing. What you can do, you can add another node to the cluster and deploy your database services on the node. So that way you can go on adding more nodes to the cluster. Not only adding, you can even delete the nodes from the cluster. If your workload is decreasing, you can remove some of the nodes from the cluster and use them for some other application. So that way, clusters provides availability and scalability in general. So that's why clusters are always preferred when you need high availability and scalability for your systems. Now, let us understand the cluster architecture. Traditionally, you have 2 types of clusters. Some vendors implement one type of cluster, while other vendors implement the other type of cluster. So broadly, clusters fall into 2 categories. The first category is shared nothing architecture or shared nothing clusters. So in shared nothing clusters, the servers, the systems or the nodes in the cluster doesn't share any resources. Okay, they are all networked together, but they don't share any resources. So you can see in this picture we have 3 nodes. Each node has its own resources, and its own storage resource also. So these types of clusters are suitable for some of the applications that where you can partition your data. Generally, your data is partitioned, and each partition is loaded into one of the server, and your application, when it sends a request for data, the system will see which partition has that data, and that system will involve in the processing of that data. So if your data can be partitioned and stored on different partitions, this architecture is suitable. And this architecture is generally used by some of the database vendors like Teradata. If you are aware of Teradata, Teradata uses this architecture. Apart from Teradata, we have some other vendors like IBM, Netezza, Greenplum, Vatica, Raxel. So these are all the database vendors that use this type of clustering for their database technology. The other type of clustering solution is shared everything architecture. In shared everything architecture, the resources in the cluster are shared. They are pulled together and utilized. All right. So here you can see the 3 nodes and the storage, which is shared with all the 3 nodes. So you have a centralized storage where your data is stored, and all the nodes will have concurrent access to the data. And any node can access any data, and any node can process any data. Unlike the other cluster where the data is exclusive to that node, only that node can see that data, access that data, process that data, because the data is exclusive to that node. All right. So here every resource is shared, pulled together and shared. So this is shared everything architecture. Oracle implements a shared everything architecture. Oracle RAC uses shared everything architecture. People argue advantages, disadvantages with these two types of clusters. Each cluster has its own advantages, its own disadvantages. Ultimately, you have to see which type of cluster best fits your business requirement. Okay, business requirement. So, however, Oracle uses shared everything architecture. So with that introduction, with that understanding of cluster in general, now let us come to Oracle real application clusters. What is real application clusters, or what is Oracle RAC? Simply said, Oracle RAC is implementation of Oracle database on a cluster. So you have a shared everything cluster, and on this cluster, you will install and configure your Oracle database. So that is what RAC is all about. Okay. So implementation of Oracle database on a cluster. Why would you implement Oracle database on a cluster? You already understood the benefits of cluster. Cluster provides high availability and scalability. So if your Oracle database needs high availability and scalability, you don't deploy it on a single server. Instead, you deploy on a cluster. RAC uses shared everything architecture of the cluster. We just discussed. We have shared nothing cluster, shared everything cluster. Oracle RAC uses shared everything cluster. So in technical terms, RAC is an option of Oracle database server that allows you to run multiple instances against single Oracle database. This is the technical definition of a RAC. A RAC is an option of Oracle database server. So what does that mean? It is part and parcel of Oracle database server. It is not a separate software. It is an option of Oracle database server which is separately licensed. So when you purchase a database license, you can deploy a single instance database. However, if you want to deploy a RAC database, you need to purchase a RAC option. RAC option is a separately licensed option. You know, Oracle database includes many options which are separately licensed. For example, you have partitioning option, right? You have similarly real application clusters option. So these options are separately licensed, and once you purchase the license, you can implement. Otherwise, a RAC is not a new software. It is a part and parcel of Oracle database software. So to implement and create a RAC database, you will install our same old Oracle database software only. Only thing is now you will install it on a cluster. And before installing Oracle database on a cluster, you need to prepare the cluster. You need to install some other software called Grid Infrastructure software. So that is the additional work involved. Okay, that is the additional work involved before you install Oracle database software on a cluster. Even after installing, the cluster administration is a little bit different. You will have so some other tools which you need to understand. You need to understand how to manage the basic cluster, how to manage the storage in the cluster, and finally how to manage what is the difference when it comes to database administration on a cluster. So today RAC has become a very mandatory skill from any DBA. So if you are a DBA, at least once in your lifetime, you will have contact with the RAC. Okay, you cannot have a life as a DBA without touching the RAC. So you have the cluster here, and you will install Oracle database, create the database. The fact that the database is shared among all the instances requires you to create the database on the shared storage. So here, this is a shared storage, right? You have 3 servers called 3 nodes. Each server has local resources, meaning each server has CPU, memory, and a local storage. But we don't create the database on the local storage. This is the external storage, which is shared with all the nodes. So every server in this cluster can access the shared storage. So the database is deployed on the shared storage. And the database instances are deployed on all these nodes in the cluster. You can decide on how many nodes you want to deploy the instances. Okay. So this is how we deploy Oracle database on a cluster. So with this, what is happening? Even if one server fails, you have instances of this database running on other servers in the cluster. So your application can continue to access the database through the other instances. Another advantage is currently you have 3 nodes in the cluster, 3 instances in this cluster. So 3 instances can handle more workload compared to a single instance. In fact, if your workload is increasing, you can add another node and deploy another instance. That way you can scale your system. So that is the advantage of implementing real application clusters. Now why RAC? By now you must have understood very well why RAC. RAC provides a high availability for your Oracle database. RAC provides scalability to your Oracle database. So if you need high availability and scalability for your Oracle database, which are the typical requirements for any important application, 24/7 application, you will deploy your database as a RAC database. So let us see how RAC provides high availability. By now you must have understood, but let us see with some diagrams. So when you deploy a RAC system, you will install a new software called as Grid Infrastructure software. Grid Infrastructure software implements the clustering and provides the availability framework, which provides availability to your database components. So one of the component that you use to provide availability to your applications is called a service. Every database can have services. As a DBA, you may be already familiar with the services. Services are there in single instance database also. But the services play a very important role in RAC environment. In RAC environment, service is a component of high availability framework. Through services, you can implement a high availability for your workloads, your applications. A database can be represented with services. Service is like an alias name. A person can have many names, right? A person may be known through different names. All those names refer to the same person. Similarly, a database can be represented with services. And the clients use services to connect to the database. Earlier, in olden days, clients use database names to connect to the database. Later, with the introduction of service concept, clients use services to connect to the database. In RAC, services provide high availability. Let us see the concept of a service. Now I have a database, and this database can be represented with services. Suppose I have created 3 services for this database. You can create any number of services for a single database. Of course, there is some limitation. I think the number is 115 somewhere. Okay, I don't remember exactly. It is around 115 services per database. Okay, so I have created 3 services for this database. They all represent the same database, and these services can be deployed on multiple nodes in the cluster. Okay, so that means you are offering your database service on multiple nodes in the cluster. So as long as the service is available on a node, your applications can use that service. If one of the node fails, the database service is available on a different node on other nodes. So as long as at least one service is available, your applications can continue to connect to the database through that service. All right. So that is continuous service. You will learn how to create services in RAC and deploy services in one of the module. But for now, let us see how Oracle RAC provides availability. The main component involved here is service. Now, suppose a database can have 3 services in realistic terminology. In realistic terms, you may create a service called OLTP. You may create a service called batch. You may create a service called reporting. OLTP service is used by your online applications that perform transactions. Batch service is used to perform batch jobs, maybe nightly loads or batch jobs. Okay, and reporting service is used by your analytical applications or reporting applications. So that way, you can even separate your workload, and each workload can be deployed on a different node in the cluster. So that way, you can better segregate and handle your workload. Not only that, you can deploy the service on any number of nodes in the cluster. You don't need to deploy on every node. You can choose to deploy on how many nodes you want to offer that service depending on the workload. For example, I have OLTP service. Currently, I have small workload, so I have deployed OLTP service on a single node. And in RAC, service can have failover. You can implement a failover for a service. What does that mean? If the node on which this service is offered currently crashes, the service can be failed over to another node. The service can be moved on to the other node. So that way, through services, you continuously provide access to the database. So let us see how it happens. So now we have OLTP service deployed on second node, and for some reason, and this application is currently connecting to the database using this service. Now, if this node fails for some reason, Oracle RAC detects this. In fact, the underlying component is grid infrastructure, which provides the high availability, and moves this service to another node in the cluster. Okay, so that way services can be failed over, meaning move to other nodes. Now this service is offered through a different node in the cluster. As long as the service is available for your database, your applications continue to access the database. So from application perspective, there is no impact to the application. In reality, in the background, the server on which your service deployed has failed, but application doesn't know about that. Okay, so that way you can mask the failures from the applications. So this is how the RAC provides high availability to your applications. Here in this context, what you need to understand is RAC may not provide high availability for all kinds of failures. Okay, so let us see what RAC is not about. RAC does not protect from database failures and entire cluster failure. If one of the node fails or multiple node fails, RAC can protect you. At least one node should be there. If total cluster fails, then RAC cannot help you. Or here you observe, in RAC environment also, you have a single database. So that could be a single point of failure. If the database fails, RAC cannot help you. Or the shared storage failure, okay, there also RAC cannot help you. So RAC will help you when one of the server fails in the cluster, or one of the instance fails in the cluster, or even multiple instances or multiple servers. RAC can tolerate n-1 failures. So in this cluster, even if two servers fail at the same time, in other words, two instances fail at the same time, I have third node and instance on that. So it won't impact your database availability. When all these nodes fail simultaneously, complete failure of the cluster, that is a data center level failure. Such failures cannot be tolerated by RAC. So in that scenario, you have to think about a different solution. We'll talk about that. What is that different solution? For now, what you need to understand is RAC does not protect you from database failures and total cluster failures. Okay, so once the shared storage or database fails, RAC will not help you. Okay, so there you cannot depend on RAC. Similarly, when the entire cluster fails, again RAC sucks. It cannot help you. So then what is the solution here? If I want to protect even from database failures or entire cluster failures, what else should I do? There comes our good friend data guard. Okay, so you can implement a RAC with a data guard, which is called as maximum availability architecture. Oracle calls this solution as maximum availability architecture, MAA. MAA is nothing but RAC with data guard. So with the data guard, you maintain a copy of your primary database. So you can have two data centers across two different geographic locations. In the first data center, you have the RAC database, primary database. In the second data center, you have standby database for this, which is continuously synchronized from your primary. So in this case, you are using RAC with the data guard. And with this, you can tolerate any kind of failure. One server fails, entire cluster fails, entire database fails, total data center failure, any type of failure can be tolerated. So once the entire cluster, entire data center, primary data center fails, you can activate your standby and your applications can connect to the new primary and access the data. So that way, if you really want a true high availability from any kind of failure, you have to implement both the RAC and the data guard together. Oracle calls this type of architecture as maximum availability architecture. If you want high availability within the data center, you can implement a RAC. Within the data center means as long as there is no impact to the entire data center, okay? A server failure, instance failure, such kind of failures, you can just use a RAC. So that way it is important to understand what a RAC is, what a RAC is not about. So MAA architecture protects you from all types of failures. All right. Now let us see the second aspect of RAC. We just understood how RAC provides availability. Now let us see how RAC provides scalability. You know, RAC is an Oracle database deployed on a cluster. A cluster will have two or more nodes, servers called as nodes. And the clusters allow you to add more nodes at runtime. So currently I have a 3-node cluster and I have my database services deployed on these 3 nodes on which I have 3 instances. If my workload is increasing, okay, if all my instances are performing at the full capacity and if my workload is increasing, what I can do, I can add a third node with fourth node and with the fourth instance on that node. So now I have additional node available to handle the workload. Like this, you can add a fifth node, fifth instance, sixth node, sixth instance, and scale out your cluster, scale out your system. Not only adding the nodes and instances to your cluster, you can also delete the nodes and instances from your cluster. So that way, you can scale out, meaning you can add more nodes, more instances to your cluster, or scale in, meaning remove nodes and remove instances from your cluster. So that way, you can scale, you can provide a scalability to your workloads. RAC provides a near linear scalability, unlimited scalability to your applications. So in summary, Oracle RAC is nothing but an Oracle database deployed on a cluster. A cluster is a group of servers acting together as a single system. In general, clusters are more reliable than single instance, single servers. Clusters can tolerate failures of multiple servers in the cluster. So RAC provides a high availability and scalability because RAC is deployed on a cluster. And a RAC is suitable for critical databases, which requires 24/7 availability and which requires scalability. So today, because most of the applications, most of the businesses are running 24/7, high availability and scalability are very important considerations for business critical applications. So this is the basic introduction to RAC. Now, let us understand the RAC infrastructure. As I told you, if you want to implement a RAC, you need a different kind of infrastructure than from the infrastructure required for a single instance database. So let us understand what kind of infrastructure you need to implement a RAC. This slide shows you the typical RAC infrastructure. So basically you need a cluster. So we have 4 nodes, 4 servers. It is a 4-node cluster, right? And you need a shared storage. Because the database, in RAC also you have only one database, which is concurrently accessed by all instances. So the fact that the database is accessed by all the instances concurrently requires you to create the database on shared storage. So you need a shared storage. So this shared storage is shared with all the nodes in the cluster. And all these servers are connected to the public network. Every server in a company is connected to the public network, which is your LAN, right? So like that, all these servers are connected to the public network. All right. So clients access the database over the public network. Now, in RAC environment, you need another network called private network. So these green lines are actually the private network. Private network interconnects all the servers in the cluster. These servers, though they are separate servers, they act as a single server. So that means they must communicate among themselves. They must coordinate with each other. There will be a lot of messaging between all these servers, and even data transfer from one server to another server happens. So all this communication, all this data transfer from one server to other server happen over the private network, which is a dedicated network for server to server communication. So that way RAC requires 2 networks. The public network, which is there in single instance database also, and a private network, which is also called as interconnect, which is used by all the servers in the cluster to communicate among themselves. The communication involves a lot of messaging between the servers, and even the instances. In RAC environment, we deploy instances on each of these nodes. So you have multiple SGS, multiple buffer caches, blocks from one server buffer cache can be transferred to other server over the private network directly without accessing from the database. So that is called cache fusion technology. You will learn all these things in the future classes. So that way, private network is very important. In fact, it should be very high-speed network to avoid any performance-related issues later. So this is the kind of hardware you need to implement RAC. What is that? You need to have cluster, which is nothing but a group of servers. And each server should be connected to public network and private network. That means each server should have minimum 2 network interface cards. One card will connect the server to the public network, which is the LAN, local area network in your organization. The second network interface is used to implement a private network. Then you also need a shared storage, okay, which is external to each server. Each server will have local resources as we discussed earlier. Each server will have CPU, memory, and local storage. But we don't create the database on the local storage of the server because the database must be concurrently accessible to all the nodes, all the instances. So that's why you need some external storage, which is shared among all the servers. So that is called a shared storage. So this is the hardware infrastructure you need. Then let us talk about the software components. On each server, you will install operating system on the local storage. All right. So every server you will install operating system. It could be Windows, Unix, Linux, whatever is supported for real application clusters database. Then on each server, you will also install Oracle Grid Infrastructure software. Oracle Grid Infrastructure implements the clustering and provides high availability to your database components. Grid infrastructure is the heart of Oracle RAC. The heavy lifting is taken care by the grid infrastructure, which implements the cluster, allows you to manage the cluster, and also provides a high availability framework to maintain high availability to your database components like database instances, listeners, services, and various other components. Then you will install Oracle database with the RAC option and create a RAC database and deploy RAC instances. So these are the software pieces that you will install on every server in the cluster. Now, Oracle Grid Infrastructure is a required software for Oracle RAC. Generally, in single instance databases, you don't deploy grid infrastructure, though it can be used in single instance databases also. But when it comes to RAC, before you install Oracle database with the RAC option, you must install Oracle Grid Infrastructure software. In fact, Oracle Grid Infrastructure consists of two softwares. One is Oracle Clusterware, second is Oracle ASM. So from 11G release 2, these two softwares are combined together, called now together as Grid Infrastructure software, installed into a single Oracle home. Prior to 11G release 2, Oracle Clusterware was there, Oracle ASM was there. But they were available as a different software, separate softwares. We used to download them separately. We used to install them separately into separate Oracle homes. Starting with 11G release 2, Oracle packaged them together, and now they are available as a single download, single software, single installation into single Oracle home. And the new name given to the software is Oracle Grid Infrastructure, which is a required software for Oracle real application clusters. Now, just now we learned Oracle Grid Infrastructure consists of two softwares, Oracle Clusterware and Oracle ASM. Oracle Clusterware is the software that implements a server cluster. Oracle ASM is the software that implement a storage cluster. Together, they implement a clustering, okay, called grid infrastructure. So grid infrastructure is nothing but pooling of the resources from different servers, right? So grid infrastructure uh, implements a grid computing. Grid computing came around year 2000. So grid computing is all about pooling resources from different computers in the network and using them together. So Oracle Clusterware allows you to pool the servers and the resources on these servers together. So each server has CPU and memory resources, right? So by implementing cluster, Oracle Clusterware can pool the resources from all these server CPU and memory resources. Similarly, the third resource is storage resource. How do you pool storage resources from different storage devices? That is done by Oracle ASM. So together, they implement a grid computing. That's why Oracle named it as grid infrastructure, which is required to implement a grid computing. All right. So these are the software components of RAC infrastructure and also the hardware components.